Hello everyone, it's Benny, and in this video, we're going to start working on a practical implementation of shadow mapping. We're going to be taking an actual 3D game engine, which you can download in the description, that doesn't have any shadowing support whatsoever. And we're going to add shadow mapping to it. And that's what we're going to be covering in this video. Now, this is going to take several videos to do. And in this particular video, we're going to be covering what you might call the boring stuff. We're going to be diving into the internals of the engine, and basically adding all the engine features we need for shadow mapping. For instance, if we're going to have a shadow map, we're going to need some way to access that. So, we're going to be going into our rendering engine, and add some way to access shadow maps from our rendering engine in our shaders and such. And, if we're going to have a shadow maps require you to, know how far a pixel is from the, in the shadow map. We need depth information. So, we're going to need to change our texture class so that it has support for depth textures. And, just little things like that. So, that's what we're going to be covering in this video. If that doesn't interest you, if you just want to get on with it, deal with the shadow mapping itself, and not deal with all the, the difficulties of implementing it in a 3D engine, or, well, all the difficulties of supporting it in a 3D engine, I should say, then that's cool. What you can do is you can go into the repository for the finished code, and you can just download the commit go into commit history, and then download the commit right before we, right before I commit all the shadowing code. That way you can have all the stuff done for you, and you don't need to worry about it. So, there you go. And, otherwise, feel free to stick around. We're going to have a kick-ass time implementing a whole bunch of engine features. Let's get to it. So, the first feature we're going to need is render to texture. And I already implemented that in another video. So, I'll leave a link to that video in the description if you want to follow along. Of course, you can also, again, do the commit thing where you just download the commit after render to texture was added and get like that, but, So yeah, one of the features is already done. And we have our example of our Mode X style graphics and our 1/5 brightness. Yeah, couldn't really think of a good example for render to texture, but hey, here you go. So yeah. And there. Now, second thing isn't really a feature, but I'd like to make our scene look a little bit nicer for the shadow mapping. For one, notice how the light on the bricks is actually sort of going the wrong way on the y-axis. That's something I talked about in the normal mapping video. If you haven't followed along with that, this doesn't apply to you, of course, but if for the normal mapping thing, I decided, yeah, I've got the point across. Some normal maps have different alignments, so I went ahead and fixed it. I created a second texture called bricks2normal.png, just so we have the old one around. PNGs, no. And that has the corrected normal map. Notice now, normals are going in the right direction. And all I did was I loaded up the texture inside GIMP. I took the green channel, which is for the y-axis, and I inverted it. And then I saved it again. That's all it takes to correct it if something like that happens. So yeah. And whoop. There. Second thing is, well, probably should have closed it, but yeah. This plane right here, one of all the really big gray bricks. They're just a little bit too big. The texture doesn't really have that resolution. You get in anywhere close to the ground and, yeah, you can tell it's being filtered and doesn't have the resolution. So, I created a new plane object, plane 4, which has different texture coordinates. If I build and run that, you notice, hey, look, it has, it's tiled, basically. We have more than one copy of the brick texture, just so, it doesn't get that, well, yeah. So we have more texture in a smaller area, I guess, yeah. That sort of thing. Good lord, it looks pixelated at this low resolution, but, hey. And finally, again, probably shouldn't have closed it, but this one I didn't have parallax mapping on so that I could show the difference between just normal mapping and normal mapping with parallax mapping. I think I got the point across by now, so yeah, let's just go ahead and add the... wait, wrong texture. Let's just go ahead and add that whole thing to this. So I'm going to delete that, add a comma, and whoop, make sure my parentheses are actually closing everything off. And there, build and run. And cool. Now everything has parallax mapping. So alright, we made our scene look a little bit nicer. It's not that much nicer, but you know, it works for an example of shadow mapping. Now, the shadow mappings is a lot more obviously the problem with this scene, rather than, oh, your thing is inverted, or oh, the texture's too big, or, you know, all that sort of stuff. So there, that's why we did that. I can delete this comment now, too. So there. Again, that's not really essential, but I think it makes the change when shadow mapping comes around a little bit more dramatic. And well, okay, in fairness, it's going to help once I get rid of the weird rendered texture stuff I have there right now, but you know, it's a start. Speaking of, let's go ahead and do that next. In the rendering engine, we have all this glorious temporary rendered texture example code. And yeah, it's all over the place, making a lot of really weird code and using a lot of global variables. That's not nice. So what I'm pretty much going to do here is I'm just going to move all the stuff into the rendering engine. Well, you know, like part of the class. Again, this is something that's not essential, but it is going to help in the long run. So let's go to the rendering engine header file. And oh, I went ahead and opened up the engine and rendering package, and that's where the rendering engine is, just in case you wondered where. Just in case you couldn't read the side of the screen for some reason. Don't know why I felt the need to read that out, but hey. Yeah, I'm going to take this slowly. I'm going to start by moving over the camera. You know, this way if I screw something up in the whole transition process, it'll make it easier to figure out where I screwed it up. So I'm going to copy the global camera variable into the fields of the rendering engine. And I'm going to call this, I'm going to rename it to alt camera, because it's going to be the alternate camera. If I ever need something that needs a different camera other than just the main camera, that's where it's going to be, the alt camera. And believe it or not, we actually are going to use this for more things than just rendered texture. Spoiler alert. So, yeah. Well, the rendered texture example, I should say. And because we do have that, we're also going to need the game object as well. So, yeah. I'm going to rename it again to alt camera object, just to make it consistent, and don't need to default it to null anymore. That's all going to be initialized in the rendering engine constructor. See, this is a lot nicer. I don't know why I didn't just do this in the first place, but, you know, well, I'm here now, I suppose. Alright. So, camera object. Wait, why am I just typing new code? I should be copying code. Alright. So I'm going to take the camera, all this camera code right here, I'm going to cut. I'm going to cut and paste. I'm going to move it up to the top right here, and I'm just going to make it use our new variables. Again, this part's mostly moving stuff around, so there's not that much here to it. It's just, well, I thought I should show it anyways, because, you know, I just don't want people to freak out like, oh, you just did 10 million things off camera, you know? No, I don't want to freak you guys out. I just want you to be able to follow along nice and easy. So yeah, getting the really boring stuff out of the way first. So, yeah, sorry, this little first part's going to be a little rough, but hopefully after this, things will be nice. So, yeah. And finally, in the destructor, we're going to delete the camera object. So if im camera object, if im alt camera object, there we go, delete it. Again, I don't know why I'm retyping this rather than just copying and pasting, but whatever, I guess that's just the mood I'm in today for some reason. Alright. Here we're using the global camera. Let's fix that. Let's change it to the alt camera. And it can't possibly be everything, right? Could it? Apparently it is. Oh, right, because I initialized the camera position in the constructor. So, alright, cool. That doesn't break anything. Alright, good. First part of things, check. So I can finally get rid of all this obnoxious temporary global variable nonsense code. Yeah, that's what I call it for some reason. And cool, let's move the material. Wait a minute. Oh, never mind. For a second I was wondering why I had a global transform variable, but no, never mind, I remember now. So now let's move around the material. It's going to be... I'm going to call it M. And material's not cutting it for me, but I'll call M material for now. I can refactor it later, if all else fails. So again, can get rid of this. Don't need that temporary deletion thing. Can change the delete code finally to something a little bit more permanent. And you know, basically the same process as the other one. The only thing is, well, I am going to need to move this down here, just because I need to know about the temporary target first, so yeah, I need to know about that. Other than that, I think we're good, so let's build. And hope we don't get an error. Forgot about that. Okay, that's fine. Just pass in whoop, wrong hotkey, and build again, and all should be good. There we go. Good. Haven't broken anything again. So I think you get the gist of it now. You know. So, I went ahead and did the rest of it off-screen for you. That way, it just saves you some time, because it's basically me doing the same thing over and over again. There's two things I think are worth mentioning. The first is, for the mesh, the rendering engine in the header file doesn't know about a mesh yet, so you'll want a forward declaration here, just class mesh, something basic. That way the rendering engine knows, hey, there actually is a mesh class, you can use it. And finally, I renamed the mesh plane, or okay, I renamed these things with plane, there. And the reason I did that is because it's more descriptive. This is all stuff pertaining to a plane object, essentially, so, you know, be descriptive with variable names, essentially. You don't need to do that at all, I just thought it'd be nicer, better practice. There. And with that, there are a few things I want to change with this whole initialization scheme here, just to clean it up a bit. And I'm going to do this on screen because this actually is something different. Where I'm initializing my temporary target, I'm starting it off with a black texture. And that's great, but we're never going to see it uninitialized, so I'm just going to start with it at nothing. That way we don't have to allocate and delete memory in here and just, you know, yeah, it's nicer this way. We don't have to deal with any of that nonsense. Second thing is, we're specifying a custom mesh for a plane. Think about that. We're specifying a custom mesh for a plane. A plane is definitely a primitive, so we're going to delete all this. You might be wondering what on earth I'm doing? Don't worry, I got a plan. You see, I went ahead and created a plane primitive. It's called plane.obj. So if I set inPlane to a new mesh at ./res/model/plane.obj, we can use the plane primitive. And this is a new model. I know I had an old one there by the same name, but this is a new one. This one has proper normals and tangents and whatnot. So you'll want to download this. Oh, I don't think I mentioned this before, but all of the new textures and models and such, they're all going to be posted on GitHub, and either they'll be with you in the starter repository, so you won't need to worry about it if you're just downloading that, but if you already have some existing code, they'll all be in the repository under the resource folder. You can just download it from there. So there. Just so that's out of the way. There. But you might notice, there's a problem with our plane primitive. So, oh, because we don't need that anymore. Cool. So what's the issue with the plane primitive? We don't see anything. And the reason is the plane starts sort of edge on. So we actually want to change the plane transform here, just to have a rotation, so it's facing towards the camera. And I don't know which way will make it face towards the camera exactly off the top of my head, so this is going to be interesting. Well, I know it's one of two ways, just don't know if it's positive or negative rotation. So we're going to set the rotation to a new quaternion, or just a regular quaternion. It's going to take in, for the axis, we want to rotate around the x-axis. Because that's, you know, right now it's just facing sort of upwards towards the top of the screen. And for the angle, I'm going to convert 2 radians 90.0f. There. And, dagnabbit, I have one too many parentheses, don't I? Yep, I do. Okay. And if you get that out of the way, this is either going to make it work, or maybe it'll do this. Make everything upside down for some reason. Yeah, sure. Okay, so I'm going to take it, I've rotated it the wrong direction, and that's why it's doing that, so let's try again. No. Huh. Okay, that's interesting. So it's upside down. Well, one moment, I'm actually not sure why that is. Okay. I got a little confused because I used this exact same code in my shadow mapping example, but as it turns out, that one has a problem too, so let's just fix it, let's rotate it. So I'm going to change this to the rotate function, just so we can concatenate rotation. So first I am going to do that 90-degree rotation, then I'm going to rotate it 180 degrees around the, well, yeah, the z-axis. And there. And now we can use the generic plain primitive, like there's no issue. And because it's bothering me, I'm going to set the scale back up to 1. We don't need to see the blue border now. I think we understand that, yeah, rendered texture does its thing. So cool. In fact, let's just go ahead and get rid of this temporary rendered texture stuff. We don't really need it anymore. I'm going to keep the code, because I'm actually going to be using this code for, surprise, more rendered texture stuff later. But, you know, for now, we don't need that. So let's just get rid of that, get rid of that. And I'm not... Ah, there we go. At regular brightness again. Much better. Alright, cool. So that cleans up most of that rendered texture stuff we had in the rendering engine. And also, I'm going to change the width and height back, you know, to full size. Again, it's going to bother me, so, yeah. Alright, great. Alright, so, finally, over 15 minutes into the video, we can finally start doing what we were supposed to be doing in this video all along, which is adding in all the different engine features we need to support shadow mapping. And don't worry, the stuff we did actually is going to help out a lot. This part should be going by pretty quick, pretty smooth. We have most of the hard stuff behind us now. So, first thing, our rendering engine. We're going to need some way to have textures in our rendering engine. And, you know, beyond just, oh, we have a texture variable. No. We need some way to have a texture in the rendering engine that we can access from our shaders. So, first thing is just making some way to store arbitrary textures in our rendering engine. So, in our mapped values, the thing that our rendering engine is extending from, you know, we can have named values here. Right now we've named vectors, named floats, and in material we're adding named textures, so let's just move the material stuff into mapped values. So, yeah, we're going to extend mapped values. It's going to have named textures now. So, we've got a texture map, the get an add texture thing, and yeah, there we go. Very easy, just copy and paste here. One thing we do need to be careful of is we now, well, materials destructor is not valid anymore. It was deleting all the textures stored in the mapped value, so I'm gonna cut this and move it into mapped values. So, yeah. So now mapped values is going to delete all the textures. So, and you know, that's kind of nice. This way we don't have to keep track of all the texture memory we allocate in the rendering engine, because mapped values is doing that for us. It'll just delete all the textures we add in the rendering engine once it's done. So that is kind of nice. And of course, it maintains compatibility with what material is supposed to be doing. That's great. Second thing I want to change is, I want to change all these. Actually, first let's build, make sure I didn't screw anything up. See? So, mapped values, we're going to need to include texture.h now, because we're using textures. See, this is why you always build when you make a change. Gotta make sure you haven't broken everything. But yeah, the next thing we're going to do, once I confirm that's working, is... Actually, what else am I going to do? Oh, right. we're going to replace all these add functions with set functions, because, you know, I don't want to just be able to add something to vector this. I don't want to be able to just add something to this. I don't want to be limited to just adding things to the map and never changing them. I want to be able to say, I don't know, we're going to change the shadow map from the directionalized shadow map to a spotlight shadow map or something like that. I don't know. So yeah, I'm going to change all these functions to set. I'm going to start with name because, well, refactoring and whatnot. But yeah, then we're going to change it. And it's actually going to make the code simpler, interestingly enough. So yeah, so material, just replace this. Oh yeah, wasn't there some like hotkey that just lets you replace everything down in a row like this? Oh well, don't remember it. So I believe the second one's going to be in rendering engine. Aha! And I think that's everything, because those are the only things that use it. Great! So it worked. We haven't broken anything. Now let's make it live up to the name. And again, this makes it actually easier. So rather than this ridiculous line of code, like, good lord. Actually, wait a minute. Oh, never mind. Sorry. Rather than this ridiculous line of code with all the insert things, what we can do is just say vector map, and then in brackets, name, and that equals value. And that does the exact same thing, but it'll add it if it's not there, but it also allows you to set it. And that's really nice. You know, I don't know who thought of that in like the STL stuff, but whoever it is, good job. That is a really nice feature. So yeah. Now it should be able to build and run, and we should be able to set things. And great! So we haven't broken anything, we got the setting features, cool. Mapped values, check. We can now have textures in our rendering engine, but we can't access them from shaders. So let's work on that next. So, here we are, inside shader.cpp. There's a function called update uniforms. It's right here. And this is basically the master function for uniforms. This is where we go through all the shader's uniforms and decide what values are sent to what uniform. And all we have to do in here is we have to look at if something's supposed to be coming from the rendering engine, and if it's supposed to be a texture, then we look at textures in the rendering engine. Very simple. Fortunately, we have a lot of that done for us, because we already have a system to detect if a uniform should be from the rendering engine. If it starts with R underscore, our system says, hey, that means it's supposed to be from the rendering engine. The problem is, what if it's a texture? Because right now, we're looking at if it's a texture first. And if it is, we're just immediately saying, okay, it must come from the material, and then just stopping. And that's not good. So let's rearrange things a bit. Let's move this, the one that checks if it's from the rendering engine, and let's do that first. So if it's from the rendering engine, then we do all that stuff. And then we're going to change our checks inside if it's rendering engine. If it's the rendering engine, and if it's a sampler 2D, if it's texture. Then we're going to do almost exactly the same thing we do right here. The only difference is we're going to, rather than getting the texture from the material, we're going to get the texture from the rendering engine. That's it. If you can get your head around that, it's that easy. Hey there, cool, we haven't destroyed anything. So, as far as I'm concerned, it's working. Also, make sure that we're getting the sampler slot and getting the texture based on the unprefixed name, unprefixed name, and not just the uniform name. Because the R underscore, that's just for the shader. That's just so the shader knows that it's supposed to be in the rendering engine. We don't need to specify that once it's in the rendering engine. So, yeah. And that just leaves one thing. The texture. We're going to need to change our texture class so that, well, in our init texture thing here, we have some way to specify what format it's stored in. Right now, we're just assuming it's a RGB texture, which is true for everything we have right now. But what about the shadow map? That's going to be a depth texture. How are we going to do that? So we're going to need to change a few things. And, well, here's how this is going to work. What I'm going to do is pretty much just add more parameters to our already... Good lord, look how many parameters it says. But yeah, we're going to add more parameters, basically. So, what I'm going to have is a GL... Pretty sure it's an enum. Yeah, it's an enum pointer. So it's going to be our array of enums for the internal format. I'm also going to have a GL... yeah. I also need a GL enum pointer for what the basic format is. You know, what format are we sending? And we're actually, believe it or not, going to need one more parameter. It's going to be just a boolean. Okay. It'll be a boolean pointer called... Well, I did not know that was a function. Is that... Do I have that specified? Oh, I specified it somewhere. Alright, that's in my math header. I'm sorry. Just got bewildered for a moment, but yeah. We're going to want a boolean for the clamp. And I am just going to make it a boolean right now, not a boolean array. Yeah, it's just going to be a boolean. So there. And that's officially the most parameters I've ever had in a single function. Well, let's count something like a matrix, which has 16 floats for initialization or something. But yeah, you know, yeah. So let's get to it. Let's take these parameters and let's make it so that we can specify them in the texture. So I'm just going to put them right before the attachment. We're going to have GL enum internal format, the regular format, and with reclamp. The defaults for these, pretty basic. Internal format's going to be GL RGBA. Format's going to default to GL RGBA. Clamp, not going to default to RGBA. It's going to default to false. You know, that's just because that's what we have right now. So, great. With all that, I think, not gonna say we have, but I think, yeah, I think that's all we need. So we just need to pass in the parameters and then, of course, use them. But other than that, I think that's all we need. So, yeah, where's the constructor here? Oh, here it is. Okay, so, oh right, but you actually need to put the parameters here. Okay, never mind. One moment. It's not the constructor I'm looking for. Okay, I'll start with this, because I can't find the other constructors right now for some reason. I think they're just down. For some reason, I'm not grouping them all up at the top like I usually do. Wonder why that is. I don't know. Anyways, so no, don't go all the way over there. I'm just gonna delete the default parameters because again, well, I didn't say that before. Never mind. I'm not going to do it because C++ doesn't let you specify default parameters twice. That just confuses everything. So yeah. And, oh, these are pointers. Be careful. So yeah. Pointers. And there, great. So now if I can ever find the constructors, we can actually use these. Alright, that is a constructor I was looking for. Dang, you tricked me. Okay, great. Well, what can I say? This is what you get when you record videos at 8 in the morning. So there, all I have to do now is pass them in like I've passed everything else into the constructor for the texture data. And that should make everything, well, other than actually using it, that should make everything work. I can just pass in clamp. Don't need the address for that. Wonderful. So, right here. Cool. And now, we need to use the parameters. So, that means init texture is going to need to take in stuff. It's going to need to take... Oh dear, I guess we can copy more parameters? I am! Wonderful. So, need to copy those parameters one last time because they're going to need to be passed into init texture down here. So, yeah. But after this, I'm pretty sure we can stop with just copying parameters around all over the place. Great. So, I'm going to use, for my format, I'm going to replace this GLRGBA with format of I. Because, you know, these are arrays. They're supposed to be. They only have one element in this implementation, but they're arrays nonetheless. And internal format of I here. Great. All we have now is clamp. Finally. So, I'll put it above. Why not? Whoop, nope. If we clamp, then I'm going to need to set up one more text param thing. This will be not the filter, but whether we clamp or not. And the parameter, of course, is going to be GL clamp. You know, this is all about clamping. And the name, I believe, is... Hopefully IntelliSense will help me, but I believe it's GL clamp... something. Okay, no, it's not. Well, one moment, I'm going to look it up, because I don't have it memorized. Oh, and one little thing. In the rendering engine, we'll need to change temp target to have all those new parameters be added to textures. So just in case you weren't tired of adding parameters to things, we need to do it for one more thing. So this is going to be just the defaults. GLRGBA, GLRGBA, and false. The reason we need that is because color attachment 0 is not the default, so yeah. There. So that should be okay. Okay, the parameter has nothing to do with clamping at all. It's GL underscore texture underscore, not clamp, underscore wrap underscore S. S for the x-axis, and T, wrap underscore T for the y-axis. Why they're S and T and not X and Y or U and V? I don't know. You got me on that one, but they're S and T, so there you go. And excellent. Let's test the code now. I think this is everything. I really do. So, come on. Oh, of course, got to pass in the parameters here. So, after filters, pass in the internal format. I should probably call it internal formats, but whatever. Format and clamp. There. Good enough for me. So let's... What? Okay, let's build one more time and let's run. Wonderful! Everything's working. And with that, I honestly think that's all the features we're going to need to add in shadow mapping. And also, kind of cool thing about this is now that we do have everything implemented, yeah, shadows are definitely the thing wrong with this picture at this point. So, yeah, no more debate about it. This thing needs shadows to look right. That's what we're going to be doing in the next video. And okay, this is going to be it's going to bother me if I don't do it, so you know, the displacement on the bricks here, the gray bricks, just they look too shallow to me. So, yeah, that's definitely an art thing, and yeah, that looks better to me. So, yeah, that's an art thing. I'm making a video about programming, so yeah. And granted, this isn't really the most artistic scene in the world, so it doesn't matter that much anyways, but, you know, it's gonna bother me. I saw it now, so yeah. Okay, great. And now I actually am gonna go check to make sure I don't have anything left to do. Good news, everyone! It appears that we've done everything we need for our engine to support shadow mapping. So great! That means everything you see here is completely shadow mapping ready. You know what? I think the bricks look a little bit too deep now. So, you know what? I'm just going to put it right back to 0.03, right where I found it, and I'm going to leave it there. This is what happens when you try to do art in a programming video. But anyways, back on topic. our engine is completely shadow mapping ready now, so great. And if you made it this far, then congratulations, because I know this definitely wasn't the most interesting video I've ever put out. But hey, you know what? At least there were a few interesting tidbits in here. We did learn how to take a rendering engine, have it have its own set of textures, and access that from a shader just by having a certain variable name in the shader. And I think that is kind of interesting. But maybe that's just me. We also talked about how we can have a texture class that supports both regular textures and depth textures in the same class. And it doesn't involve 10 million different conditional branches or a bunch of, other wonky coding things. It doesn't even need special data system. We just add different parameters to the constructor and it just works. I think that is pretty cool, but hey. So yeah, I think this video had its moments, but, it wasn't the best, so congratulations if you made it this far. You've earned it. Because in the next video, that's where the fun happens. That's where we take all these different things we've put together, and it's where we really start adding in shadow mapping, and things get interesting. So thank you. Hope you enjoyed. Hope you learned. Hope you forgive my over-enthusiasm in this video. I don't know what's up, but what can I say? I love programming. I'm in a good mood. Guess this is the only logical, result of that, but hey. So thank you. Hope you enjoyed. Hope you learned. And see you next time.